Hello and welcome back to the channel. So today we are discussing the first problem for stacks and queues series. And this is a really nice problem actually to get a good understanding of the concepts of both queues and stacks. It is definitely a very easy problem, but a really good practice problem. The problem we're discussing today is Leetcode problem 225, implement stack using queue. So there's another variant of this problem which requires you to implement a queue using two stacks. So I would recommend you to solve that problem on your own after watching this video. The solution for both the problems is almost identical. So first of all, let's go through the problem statement. So it states that implement a last in first out stack using only two queues. The implemented stack should support all the functions of a normal stack: push, top, pop, and empty. So basically, we need to create a data structure that would function like a stack that is last in, first out, and it should have all the basic operations of stack like push, top, pop, and empty. So push is basically you push a new element to stack or you insert a new element in the stack. Then pop is that you remove the top element of the stack. So the last element that was inserted in the stack gets removed. Top is basically you get the last element that was inserted. So you get the value for the element. But yeah, it is not removed from the stack. So pop removes it. And empty is a function that checks whether the stack is empty or not, whether there is any element in the stack or not. So we will follow a slightly different approach in this video and use an example to come up with the logic. So let's say that we have two queues. One is the main queue, another is the helper queue. So the question says that we can actually use two queues to implement this stack. So I've taken one as the main and another as the helper. Now we need to insert six elements into this queue. So let's say these six elements that we need to insert are 1, 2, 3, 4, 5, 6. Now, everything, all the storage and inserting elements we are going to do in the main queue. Helper queue is just a helper data structure that will help us in performing operations and in a last in first out manner. But the main storage will always happen in the main queue. So inserting elements in the queue seems pretty simple. So in for inserting these six elements, what we'll do is we'll go and simply uh, insert this or enqueue it in our queue. Now this is how our queue is actually going to look like, with the front being at 1 and elements being inserted at the back. So the insertion operation seems pretty simple. It is as simple as enqueuing the elements into the queue. Now let's say that we want to pop an element. Now if we directly pop the element from the queue, we will get the first element 1. But since we want it to behave like a stack or last in first out, pop should actually remove 6. So how do we reach 6? So the only way that seems possible to reach 6 is that we have to start removing from the front of the queue, and then eventually we'll reach 6 when we'll reach the last element, because there's no way I can directly access 6 in a queue because I can only access the first element because queue is first in first out. So the only available option is that I dequeue elements till I reach the last element. But I also need to store these dequeued elements because these do not, because I do not want to remove these dequeued elements from the queue right now. So there has to be some additional space where I would have to store them so they can so that I can even after removing 6 I can eventually add them back to my main queue. So that is where this helper queue comes into picture. We are going to use it as a temporary storage for the elements that are being removed from the main queue for popping the last element of the queue, and till then the helper is going to store the other elements. So first of all we'll dequeue one and we'll enqueue it in our helper for temporary storage. So one will be removed from here. Then again we'll dequeue two. So first we'll dequeue 2, it will be removed from here, then it will be added to helper. Then we'll remove 3, it will be dequeued from the main queue, and then it will be added to the helper. Similarly 4 will be added and 5 will be added. and those will be removed from the main queue. Now eventually we'll reach the last element of the queue. So when the size of the queue is 1, or we have reached the last element, we dequeue it, but we do not add it to our helper queue because this needs to be removed from the queue. Now our queue is going to be empty and our helper queue is going to look something like this because it is going to have all the elements from the main queue. Now what we have achieved is that we have removed the last inserted element from the queue. So we have done our stack operation of pop. Now what we need to do is that we need to empty this temporary storage and push these numbers back to our main queue, because this is just a helper is just a temporary storage. All the elements stay in the main queue. So what we'll do here, again, we have no choice but to start popping out from the front and keep inserting into our main queue. But we see that due to the FIFO nature of the queue, the elements, when we pop them from the helper queue and insert them into the main queue, the order of the elements in the main queue remains same or similar to what it was before. We have not actually changed the ordering of the elements in which they'll be inserted again in the main queue. So if we see, we'll first pop 1 from helper and it'll be inserted in main. Then 2 will be popped from helper. Subsequently 3, 4 and 5 will be popped from the helper and inserted into the main queue. So, and these will be removed from the helper queue. So what we can see is that we have actually removed the last element and again inserted all the elements in the same order or their original order into the main queue. So we have actually completed the last in first out pop operation as it should have happened on a stack. So we have seen how insertion works. We have also seen how uh, pop or delete works. Now another one is empty. Empty is very simple. We just need to check whether our main queue is empty or not. So depending on that, we need to return a Boolean value. The last operation that needs to be handled is the top operation, where we return the last inserted element in the stack. But in a queue, we have direct access to the front element or the first inserted element. We do not have any access to the last inserted element. So for that, what we can do, that in a stack class, we can maintain a different variable top, and we while insertion and deletion, we'll accordingly update the value of this variable top, and whenever someone calls the top method, we'll simply return the value which is being stored in top. So whenever insertion is happening, we'll update the value in this top variable, and whenever deletion is happening, we'll again update the value in this top variable, and always the top element or the last inserted element in the stack will be stored in this top variable, and we'll simply return it in the method. So we could have followed the same technique, that we could have dequeued the elements, inserted it into the helper stack, and then see what was the last element in the queue and return that. But the time complexity for dequeuing all the elements, inserting them into the helper, then dequeuing it from helper and again enqueuing them in the main queue, the time complexity for this operation is big O of n, because it's a linear operation. We would have actually traversed the whole queue. But by maintaining this top variable and simply returning the value stored in the top variable, it's a big O of 1 operation. So by maintaining this extra variable, we have reduced the time complexity of getting the top element from big O of n to big O of 1. So when we are looking at the code, we'll again look at all the time complexities for all the operations carefully. So now I think we have understood the basic logic of how insertion, deletion, empty, and top are going to work. So let's quickly jump to the code. So this is the code for this problem. So as we have already discussed, we are actually going to maintain two queues. So one is the main queue, which has been referred to as stack here because it is the queue which is going to act as a stack. And then we have a helper queue which has been named as helper here. This helper queue is going to act as a temporary storage during our pop operation. And also, as we discussed, that to reduce the time complexity of top method, we are going to explicitly maintain a variable which is always going to store the current top element of the stack, and we have named this variable as top element. Now we have the constructor for this default constructor for this class. In this, we have initialized top element as -1, because right now initially the stack will be empty and there will actually be no top element. Now the insertion or the push operation is very simple. So as we discussed, it is as simple as inserting an element into the queue. So stack here is actually a queue, so it's a bit confusing. The a variable is a queue which has been named as stack, so it's a little confusing. So here what we are doing, we are actually inserting this element into the queue directly, and as we discussed, that insertion is as simple as inserting the element directly into the queue. And whenever a new element is inserted into the queue, the last inserted element, which is the top element, like the definition of top is actually the last inserted element in the stack. So whenever a new element is inserted, obviously the top will be updated because that element will become the top. So we have also updated the top variable, and we have put the value of the new inserted element into top. Now, next is the pop method. We'll quickly come back to the pop methods. Let's see other methods which are pretty simple. So we have the top method. In top method, as we've discussed, it is as simple as returning the top element, the value stored in top element, and bool empty. So if the size of our main queue also being referred to as stack in this particular code, if the size of that queue is empty, then the stack is empty. So what we do here is we just return a boolean based on whether the stack is empty or not. The size of the stack is 0 or not. Now finally we come to the pop operation. So in this operation we are actually going to do two things. So one thing is that we need to dequeue all the elements from the main queue, enqueue them into the helper queue, remove the last element, and again dequeue all the elements from helper and enqueue them back to the main queue. Also, we have to take care of the top element because the current top is actually going to be removed from the stack. So we have to change the top element as the second last element of the queue. So the two things that we are going to do here is we are first actually going to pop or dequeue all the elements till the size of the queue is 1, because all these elements have to go into the temporary or helper queue because they have to be enqueued back. So till the size is 1, we'll dequeue all the elements. So we are getting the front, which is like the first element of the queue. We are getting that element and we are pushing it to helper queue. So that's what we have discussed, dequeue from main, enqueue into the helper, and then we are removing it from the main queue. So these two steps are actually representing that operation. This particular if condition is for changing the top element. So as we have discussed, the last element is going to be removed, so it cannot be top anymore. The second last element will become the new top. So what we are doing when the size of the stack is only 2, so the front of queue right now is the second last element. So like what we are saying, A, B, C, D. The current top is D. So once we have dequeued A, once we have dequeued B, we are left with two elements. So the size of the stack is 2. C and D have been left, and we know actually that C has to become the new top. So this being the current front, this has to become the top. So this is exactly what we have done in this condition. When the stack size is 2, the new top element is going to be the current front, which is C. So this particular while loop takes care of two operations. First is if we have n elements currently in our stack, it removes n minus 1 from the main stack and enqueues them into the helper queue, and also it updates the top element. Finally, the only one element which will be left in the queue is popped from the queue. It is removed. We do not have to track it anymore. It can be deleted, and the elements which were inserted in the helper are going to be inserted back into the main. So they are removed from the helper and inserted back to the main in the same order as they were removed. So now our queue is going to be in the original state with the last element being removed, and we simply return this last element. So this last element has been removed, and in this method, so it was given in the question that the pop method has to actually delete the element and also return the last element which has been deleted. In the usual pop method which are implemented in STL, the pop method does not return anything, it simply removes the last element. But here we also have to return it. So quickly coming to the time complexities. So insertion or push is O1 operation because we are simply calling push on queue. So inserting element in queue is O1 operation. So time complexity for top is also big O of 1 because we are simply returning a variable. And empty method is also big O of 1 because we are simply doing a conditional check here. Pop method is going to be big O of n because we are actually traversing the whole stack in dequeuing elements one by one and queuing them. So it's actually big O of 2n, but which is same as big O of n. So due to the linear nature of the operations, it is big O of n. So I hope that you have understood the question. The question was pretty simple. The solution is also pretty simple, but it's a good question if you have just started with stacks and queues because it attacks the very fundamentals of stacks and queues. And as I said that there's another variant where you need to implement a queue using two stacks, so you can try that on your own. And in case if you still have any doubts in this particular question or the other variant, do mention in the comment section and I'll address all your doubts there. So see you in the next video. Thanks for watching. Bye bye.